Hi, my name is Paula Daccarett, and I'm going to teach you how to find the tension in ropes 1 and 2. The following diagram consists in this. Okay, this is a diagram that we're going to be solving. The first step is to find the force of gravity in the tension ropes. In order to do this, we have a formula, which is force of gravity is equal to mass times gravity. So the force of gravity would be, in this case, the mass is 11, as we have here. So 11 times gravity, that as we know, is always 9.8. This will give us 107.8. So we're going to separate the two triangles by forming the coordinate systems so we can solve this problem. So we divide this in two. The first one is going to be this one that we see right here. And the second one, this one. 40, x2, the x direction, y direction, y2. The same for the second one. 50, x1, and y1. Okay, so now we're going to split into x and y directions so we can organize our information, basically. In the x direction, we're going to place the following equation, x and y direction. We're going to place t1x minus t2x is equal to 0. And now we're going to replace the variable x by cos, as in SOHCAHTOA, 50 and cos 30, since the x direction on both triangles is adjacent to the angle. So T1 cos 50 minus T2 cos 40 is equal to 0. Sorry, I don't have enough space. Now we're going to isolate T1 by dividing by cos 50 on both sides. Now we'll leave the x direction alone and start filling the y direction. Now we're going to start with the y direction. In the y direction, we're going to place the following equation. T1y plus T2y minus 107.8, which we got it, which is a force of gravity that we got it mass times gravity, is equal to 0. When we are finished plugging the following equation in the y direction, we're going to replace the y variable with sin 50 and sin 30 as we did in the x direction, but now we're going to do it with using sine instead of cos. So T1 50 plus T2 sine 40 is equal to 107.8. As you can see, I passed the negative 107.8 to the other side positive. We're going to use sin because the y direction is opposite to the angle on both triangles, as we can see here. Now, you take with what you left in the x direction and plug it in the y direction. You will be left with the following equation. T2 cos 50 times C 50 divided by cos 40 plus sin 40 is equal to 107.8. Now we're going to use our calculator to solve for T2, which gave us 1.29 is equal to 107.8. With the answer we got for T2, we're going to plug it into the equation you were left with in the x direction. Now plug it in the calculator to get the answer. So we'll do T1 is equal to, first let's finish with T2, 83.57. We're going to plug this in the x direction as I said before. So T1 is equal to 83.57 cos 50 divided by cos 40, and T1 will give us 70.12. We're going to get this answer by plugging this in the calculator. So now we have T1 and T2. So the rope 1, the tension of the rope 1 is going to be 70.12 newtons, and the tension for rope 2 is going to be 83.57. Don't forget always to include direction in this type of problem. So the final answer, wait 1 second. The final answer will give us rope 1 70.12 newtons, x 15, x, y, and rope 2